We've got a nice light question to begin with. It's not, I think, but it might be very, very difficult as well. Which is Martin would like to know who's going to play Ernest Rutherford in the movie. Now, this is always an interest because I was talking with an actor the other day who was complaining about the fact there are so few movies that are really about scientists. Even the movies about the scientists end up normally being about a romance, and sometimes a highly fictional romance in terms of that Alan Turing film, which was kind of. But it's an interesting. If we did finally start to get movies that were being made where the science was up there as part of the story, who do you want to be? Now Martin has suggested early on two New Zealand actors, Sam Neill, the wonderful, brilliant Sam Neill, Rhys Darby. And then he's also suggested Mike Wozniak, who is currently doing Taskmaster and has a very big and strong moustache. So I presume that might be one of the elements. So let's start with you, John. Who's going to be your Ernest Rutherford? And also in that movie, because you're only allowed to do so few things, what would be the part of his life that you think, I'm going to focus on this because this is the work that I most want people to understand?
Okay, you threw me with the last bit, but I think he's a bit of a superhero, so he's got to be one of the Chris's, I think. I don't know which Chris really, but one of the Marvel Chris's. Probably the one who did Captain America, but I'm not very good at remembering actors' names. But Chris Hemsworth, no, he was Thor, wasn't he? Thor he'd be good. The Thor guy would be good, actually.
Smashing atoms with a hammer.
Yeah. One of the MCU Chris heroes.
And he's hemisphere as well, so I mean, he's at least partly. I think he's Australian. Jim, who's your
Kiwis, though? How
Sorry?
cross would New Zealand be if you got an Australian to play Ernest Rutherford?
Sometimes you just got to be happy with being the same hemisphere. Okay, that's just the way it works. Jim, who's in your casting? And again, the bit that I didn't. So in those movies, they like to kind of. You can't have too many things because we've always been presumed as audiences are idiotic. So I was wondering which particular part of his experiments and which particular discovery you would think this is the one that I'm going to put in my big budget Hollywood Ernest Rutherford epic.
Obviously, the gold foil cannonball thing, right? I mean, you could have one of the Infinity Stones in the gold foil or something. It's a no-brainer.
Well, tell you what, I wouldn't have John's choice. That's a ridiculous choice, having Chris Hemsworth playing as Rutherford. Actually, I think Sam Neill will be very good. He played that copper in Peaky Blinders, so he had a really good Rutherfordian tash there. So I think he has the right gravitas, I think, for Rutherford. And yeah, he'd play Rutherford sort of the youngish Rutherford, 1900 and something, when he first arrives in Britain from Canada, and probably all the way through to sort of 1920. I mean, it's that is the period. By the way, Robin, that the lecture he gave with Kelvin asleep in the front row, it was in the Royal Institution. I did check. Phew, it would have been bad if we said at the Royal Society. Can you imagine? I'd never be invited back to the RI. But yeah, so Sam Neill's my choice, I think.
And Linda?
I'm afraid I'm not very familiar with these Kiwi actors, unfortunately. So I think I would go, just like John said, with the golden foil in terms of which part of his life to focus on. But I'm wondering why not an animation film. There's been quite a lot of very good animation films in the past few years, and also so many really good of them from the 90s coming out of Japan, especially. So I'm thinking an animation film, and it's an opportunity here.
Oh yeah, Pixar at the beginning. Yeah. No, that would be good. Now we've had a question. I'll stay with you, Linda. This is from T. Rowe, who would like to know: do neutrinos interact with electromagnetic fields?
No, unfortunately, no. Neutrinos are neutral, so they cannot interact with electromagnetic.
John, this is from Rufus. Rufus would like to know: how does the 1% of antimatter exist? Why doesn't it annihilate?
It does. That's why there's so little of it. I mean, there's less than 1% of it. If you make some antimatter, which is not hard to do. In fact, my son did work experience at the antimatter factory at CERN, which is okay, factory, it's more of a cottage industry. They make a few atoms here and there. But even so, you can make it fairly easily if you have the energy. But the effort is keeping it from coming into contact with any matter, because it will annihilate. And that's and as Linda mentioned earlier, the big puzzle is why if there was equal amounts of it around at the beginning after the Big Bang, why didn't it all annihilate and destroy the matter with it? But yeah, it does. So it can exist in a vacuum, and you have to work quite hard with magnetic fields to trap it and keep it if you don't want it to annihilate. But if you just leave it on its own, it will.
Thank you.
I just say I love the idea of the the antimatter factory is now like Willy Wonka's chocolate factory, with like magical things flowing everywhere, and neutrinos and anti-neutrinos and antimatter just popping out of things. I think that's a great mental image. I hope it looks like that. Don't say anything. I don't want to know if it doesn't look like that.
Okay.
Don't destroy her Oompa Loompas, okay? You just keep them real.
I've noticed my son is going to be called an Oompa Loompa from now on, but there we
go. This is from Eleanor. Eleanor's in year 8, and she wants to know, we learn about atoms, neutrons, protons, and electrons, but not about things like neutrinos and muons. Why not? Jim, why not? I mean, I presume maybe after year 8 there'd be...
I think it's because the protons, neutrons, and electrons are the constituents of atoms, and atoms are basically what everything matter is normally made of. So most of the science that we learn at school doesn't need to take into account that the neutrino is part of that family with quarks and electrons. And it does get complicated. The number of elementary particles exist in the standard model, does become not quite Rutherford stamp collecting, but there's a lot of them. So the minimum needed that we need to know is an atom, and it's made of protons, neutrons, and electrons. Of course, the protons and neutrons themselves are made of quarks. So in reality, you could say everything is just made of 3 kinds of particles: up quarks, down quarks, and electrons. And then you have to apologize to the neutrino physicists and say, well, actually, neutrinos are also important. They're not just there to make up the numbers, although they sort of are a little bit.
Now, by the way, I've also got good news for anyone who this kind of Veruca Salt fantasy that Helen was having there about the Willy Wonka chocolate factory. There is on Cosmic Shambles or on Matt Parker. I think Matt Parker, a stand-up mathematician. There is a film of him at the antimatter factory at CERN, and it's on YouTube. So look up Matt Parker, and who you probably will know anyway. Just does wonderful work and great films. R. Andrews would like to know: do neutrinos gain mass via the Higgs mechanism, or do they lack Yukawa coupling? That's Linda.
Yeah, we do. Well, we do gain mass from the Higgs mechanism, but we don't know yet how much it couples with the Higgs yet. So we don't know what's the neutrino mass. So we've set boundaries on it. We know at most is 1,000 times lighter than an electron. That's how light it is. But we haven't yet measured the neutrino mass.
Is it true also actually know whether it all comes from the Higgs mechanism?
Yeah.
So that we know that part of the neutrino almost certainly does couple with the Higgs, but because they're neutral, there's another way they can acquire mass called a Majorana mass term, which I always worry about saying. But they have a Majorana mass term possibly that they're allowed to have that no other particle can have, and there are experiments, as Linda well knows, going on to see if that exists as well. So they get some of their mass from the Higgs, but maybe not even most of it, actually.
And if they were, Majorana particles, that would also be a huge discovery. And a Majorana particle is a particle that it's its own antiparticle. So that would be like going beyond, when I was telling you that antineutrinos were neutrinos' evil twin, that's like proper split personality. So like antineutrinos would be, neutrinos' own nightmare.
So we'll have Jed. That's good. Mohammed Salim would like to know, what do you all think is the most enduring legacy of Rutherford? So, Jim, if I start with you, and then we'll go through everyone.
I think he presided over the golden age of nuclear physics. So really sort of the 1920s, 1930s. We know about the gold leaf experiment, but for me, it's overseeing the first nuclear reactions, the building of the first experimental facilities, getting public funds to run big research programs, and overseeing, being the father figure of so many other great scientists who went on to make a contribution to physics.
Helen.
Jim's just listed everything.
Sorry, that's
I think Jim's making up for your intro where you did everything he'd ever done in 7 minutes. So I think it's just a tit for tat thing going on here.
Well, I mean, so he was a speaker, right? He shared what he did, and he was known to be an entertaining speaker. I think he wasn't, he didn't hide away. There's lots of myths and sort of stereotypes of physicists, but this guy clearly had presence, and I think that at the time that adds to, in the sense of physicists weren't these shy retiring people in the corner, that he walked into a room and people knew he was there, and that as a sort of advert for physics, I reckon that was probably pretty important, although not as important as the things Jim said.
John?
Right, well, I can't really disagree with any of that, so I'm just going to add to it. I think Feynman actually said that if we lost all our physics knowledge, what would be the most important thing you could tell people to help us recover it again as quickly as possible? And he said everything's made of atoms jiggling around, little atoms jiggling around. And I think, given that Rutherford was the guy who basically nailed that and said, yes, it is made of little atoms, and this is what they look like, then I would say that has to be a bit of a killer. But I must say, I'm really impressed that Jim and Helen both went for basically sociological issues with him, in fact, leadership issues and politics. And I think that's correct. I think that is his biggest real legacy, to be honest. And it's worth mentioning, maybe there are many scientists who have legacies like that, who never made big physics breakthroughs themselves either, but have supported generations of physicists who did.
And Linda, you've got the toughest in now. There's 3 answers already. So you can just say, I agree with all of the above.
Yeah, I mean, like, is there anything you just mentioned? Yeah, it's just like so difficult to choose. Jim, Helen, and John basically covered everything already.
Good. In fact, we almost don't need to do the rest of the questions. I think everything's been done. But this is a question from S. McNeil. And I'll ask you this, John. Could CERN be classified as the gold leaf's experimental descendant? Absolutely.
Yeah, no doubt about it. And we, as Jim mentioned, I think earlier, we particle physicists own Rutherford. I'm sorry. He's our father. Never mind those nuclear guys, although, of course, you do nuclear physics at CERN as well. So fine. But the N stands for nuclear. So there we go. Yes, definitely. In the way I said, it's about energy, basically. Rutherford saw the nucleus because the alpha particles had enough energy. We saw the Higgs because our beams had enough energy. It's the same deal.
And just on the question of owns Rutherford, so one of the other things I found out while looking up about all this was Rutherford's crest of arms. So he was a Kiwi, and it is well worth looking up. So when he became Baron Rutherford of Nelson, which is the place in New Zealand he came from, so his coat of arms, it's got a Kiwi sitting on top, and it's got a Maori warrior at the side, and the lines crossing the shield are D curves. So his coat of arms, like, he clearly really thought about this, and the New Zealanders, they're pretty sure they own it.
Now, this is for you, Jim. This is from Paul, who wants to know how much you know about Rutherford's views on nuclear fusion.
Nuclear fusion? Well, now that was a bit later than Rutherford's time. Famously, people were obviously starting to think in the 1930s about nuclear fission, so splitting the atomic nucleus. And there's famously, Rutherford didn't believe that was going to be possible. Certainly, it wouldn't be possible to generate energy, usable energy from nuclear fission. He believed it was moonshine, I think is the quote. But actually, he did really. There are stories of him talking to government officials in the UK about the possibility of nuclear fission being used for defense. In fact, he said, he actually told people, keep an eye on progress in this area, because it may well be that the energy locked up inside the atomic nucleus could be utilized in some way. But fusion, actually having two lighter nuclei merged together to make a heavy nucleus. That was something that would come slightly later. It wasn't until the late 1930s that even sort of fission was understood. So he was slightly before the time of fusion.
Thank you, Jim. That was a question from Johnson. Now, this could be a big one. Johnson wants to know, this is one of those ones, your thoughts. So, thoughts on a wholly superdeterministic model of the universe. Would we ever be able to realise this as true? Further, could we ever disprove this in any way? So, the superdeterministic model. I've checked there the wideness of your eyes as you heard that question, Linda. So, I'm going to throw it to you first of all.
I'm not sure I want a super deterministic model of the universe. You know, it wouldn't be fun. No, I mean, I'm not really sure it would be possible. If we think about the Heisenberg uncertainty, like the amount of information that we can know about things is not infinite. There is a quantum sort of finite element to what we can know, and this is a property of matter. Is not a property of our measurements or a property of our theory. So I don't really see a deterministic model of the universe that will give us all the answers.
Who was John?
I kind of agree with that. I think we know that. So from things like chaos theory, we know that tiny effects in initial conditions can have, in the end, very large effects in where macroscopic things end up. I mean, the cliche is the butterfly causing the hurricane or whatever, but it's certainly true that even a compound pendulum, you can't predict its motion after a few oscillations in practice, because you can't measure its initial condition, its initial position, even classically, right? There's no quantum mechanics in that. You can't measure it precisely enough. No matter how precisely you measure, in the end, the nth decimal place you couldn't measure will have a measurable impact on where it ends up. So it's not deterministic in any practical way, even though that's a completely classical system with a completely deterministic theory behind it in principle. So once you throw in what Linda mentioned, the fact that our current understanding of quantum mechanics is there are no hidden variables, there is a genuine limit to how much you can specify the initial condition. And in particular, you can't specify the position and the speed at the same time, then to arbitrary precision, then no, there's no possibility of this. There are people working still on hidden variable theories of quantum mechanics, but I'm skeptical of both of those theories. And even if they worked, you'd still have the compound pendulum problem that you probably in practice couldn't measure them anyway.
Helen, do you want anything?
No, I don't think so. But I also agree with Linda that a super deterministic universe would be really boring. Don't want any. That would be the worst of all the universes. A boring one would be the worst type. I am prejudiced against boring universes, and we don't live in one, so that's a good thing.
That's what I remember talking to some cosmologists. I think the end of last year, Katie Mack and various others, and it might have been Chris Lintott who said that's one of the most depressing things, is that the universe does become boring towards the end for an enormous amount of time. All of these fantastic and beautiful things we can experience, see now, and then you just go, every now and again a blue whale comes into existence or a Boltzmann's brain, but apart from that, it's a lot of nothing. So
say that in a Brian Cox voice, Robin.
I think it's wonderful. Eventually the universe is going to be boring, which is one of my favorite things. It's just beautiful. There's nothing happening, and I might be a Boltzmann's brain. So we've got one final question, I think. I haven't done his voice. I haven't seen. Well, I have seen him, but only online for a while. I think it affects the impression. He's stolen more of my hair during this lockdown.
During that impression, Robin, you looked happier than I've seen you all year.
But it's the only way you can do it, because you can't do, in the same way you can only do Brian Blessed by doing this like that. You can only do that. You can only do Brian by doing that. You can't, because no one sees him on telly going, "Don't like this bit of the." You see, the moment you turn the voice to it doesn't come out. No, so anyway, Waleska would like to know, do you think we will find the proton decay in our lifetime? Jim?
I mean, there are still physicists who are holding out for the possibility that the proton isn't a completely stable particle. There are limits now on just what its half-life is. It's you don't have to wait for one proton for billions and billions of years. What you have is lots and lots of protons, and the hope statistically that one of them will decay. This is one of the predictions which John will know more about than me, at least some of these ideas in particle standard model of particle physics, that if proton decay is true, then it suggests certain theories are right. But personally, I'm skeptical, not because I haven't seen it happen, therefore it's not going to happen, but there's only so long we can sit around waiting for certain predictions, theoretical predictions, to be experimentally observed.
Also skeptical. You're a scientist. It's really very much part of the job, isn't it? I feel. John?
I'm also doubt it, partly because people have stopped looking. There was a period when people were building bigger and bigger proton decay experiments, and now
harder to see if people are not looking.
So, the Kamiokande experiments that discovered neutrino oscillations, a lot of the technology there came from proton decay experiments. In fact, a lot of it developed at UCL. In fact, but I think I'm skeptical. However, I have to say that we mentioned earlier these weird, these couple of measurements, the one at LHCb and the one from Fermilab, that are not in total agreement with the standard model at the moment. One of the explanations for them might be the existence of a particle called a leptoquark. And a leptoquark is some intermediate particle between a quark and an electron or a lepton, which would enable, most of them would enable proton decay at some rate. So maybe we've seen the first glimpses of a resuscitation of the interest in proton decay, which means people might go looking for it again, which means we might see it. I don't know.
I still have a problem with this quark thing. Now, I've talked first before, I don't know if anyone else has this, because as I've said to John before, as far as I know, that word originally comes from the work of James Joyce, a quark for Mr. Mark, not a quark for Mr. Mork. A quark for Mr. Mork is an entirely different scenario. So this is another reason I can't go into physics. It's not because I just don't understand it. It's also I'm not happy with the rhyme scheme always.
You're making a huge mistake in trying to analyse James Joyce with anything approaching logic.
That's true as well. I've got to admit, Finnegan's Wake, yet again, I took it out of the shelf and moved it to another shelf. One day, I imagine, one day.
If you read The Quark and the Jaguar by, and I pronounce it advisedly, by Murray Gell-Mann, who's the guy who coined the phrase, he says, I know it should be Mark, but I know it should be quark, but it's quark. And he's the man who invented it, so...
Also, for Murray Gell-Mann, I have to say one of the most useful things for a non-scientist, Murray Gell-Mann amnesia. I don't know how many people know about this. Was his idea. He said whenever he would read an article about physics in the newspaper, he would go, well, that's all wrong. And then he would turn the page and read the rest of the news and just presume that it was. And then he'd suddenly think, hang on a minute, why would it just coincide? It just turns out the only thing newspapers don't know about is the thing that I do know about. And it's, again, going back to skepticism, as you mentioned, Jim, I think it's a very good way of keeping our skepticism active. Thank you so much to Linda, to John, and to Jim. And I hope everyone's enjoyed this. Thank you, obviously, as usual, to you, Helen. We'll be back on Sunday.